Hello, so this is take two of trying to do my video on the area of a circle. The first time I was most of the way through a beautiful diagram of where the area of a circle comes from, just like we've done in class with all the animations, and my laptop decided that that was the moment it wanted to freeze for about 10 minutes and just stop working entirely. So instead I'm going to go over this quite simply, again just as a wee reminder for you of where this information and where this formula comes from. Okay, so to begin with, we have, well, we don't have whatever that shape is. We were trying to draw a circle. We have a circle, and as well as that circle, we are going to look at a shape that we're all very, very familiar with. We're going to look at a rectangle. Now, if we think back to when we did this in class, we talked about how the area of a circle comes about, where we take this circle and we split it into slices and we arrange them in a rectangle, and then we split it into even smaller slices and we arrange them around this rectangle, and we keep making smaller and smaller and smaller slices over and over and over and over again until finally the slices fit absolutely perfectly into that rectangle. And then we think about where the dimensions of this rectangle come from. Well, the base, the length of the rectangle, comes from the outside of our slices, covering half of the radius of the circle. The width of the rectangle comes from the radius of one of the slices, and that's what then allows us to get our formula. So this, as we said, was half of the circumference, so half of pi d. Half of the diameter, recall from our last video, is the radius, so that becomes pi r. Then the other side of this is the radius. Now we go back to our familiar formula for the area of a rectangle. So the area of this rectangle, and therefore this circle which has been fit into it, is length times breadth, which is pi times r, pi r, times r, which equals, we wouldn't write r times r in a formula like that, we would write pi r squared. So the area of our circle is our formula pi r squared. Okay, and let's go on and use that a little bit. Okay, so here I have a circle, and I am going to start relatively straightforward, and I'm going to say that that circle has a radius of 2 centimeters. Okay, I'm going to look at laying out my formula and working this out. So A for area is pi r squared, which is, I'm not using a calculator, 3.14 times 2 times 2, which is 3.14 times 4. This is relatively straightforward to do without a calculator. Again, you could look to do it in your head or write out a calculation. Multiplying by 4 I should be okay to do in my head. The 0.14, well, if I multiply that by 4, I am going to get 0.56, and 3 times 4 is going to give me 12. So 12.56 centimeters squared would be the area of that circle. If you don't feel like doing that in your head, you can't use a calculator for numbers like that always, but there's no harm in just laying it out like a multiplication sum. Okay, let's look at another example which will tie in a couple of things. So in this example, this circle, I am going to be given the radius. Sorry, I'm going to be given the diameter. And I'm going to say that diameter is 16 centimeters. Okay, so remember that my formula uses a radius, not a diameter. So I need to work out what that radius is going to be. It's half of the diameter, so the radius is 8 centimeters. Okay, let's look at a little bit of tactics for doing this without a calculator. So A for the area is pi r squared. So A is going to be pi, or 3.14 times 8 times 8. Okay, so what I'm now looking at is having to do, if I was to lay it out as a calculation, 3.14 times 8 squared is times 64. That means that I am going to have to run into, using our familiar long multiplication algorithm, which potentially means I am going to make a mistake. It could happen. So I want to avoid doing that if I can. I don't need to multiply by 64. I can do this multiplication in steps. I could do 3.14 times 8 to give me the first part, and then I could multiply my answer by 8. It means I'm doing two multiplications, but they're each a little bit easier and a little bit less likely for me to make any careless errors. So that's how I'm going to do this. I'm going to do 3.14 multiplied by 8. A little bit of short multiplication with decimals. So 8 fours give me 32. 8 ones give me 8. If I add on the 3, gives me 11. 3 eights make 24. Add 1 to give me 25.12. Now I can do 25.12 and multiply that by 8. And well, this I could almost do it in my head, but I'm not going to. But I am going to look at 25 times 8. 25 times 8 would be very roughly, it would be 25 times 8 would be exactly, rather, 200. So 25.12 should be just slightly over 200. If I make a mistake and I get an answer that's wildly different from that, I know I need to go back and look at it again. So 2 eights give me 16, carry the 1. 8 ones are 8, add on 1 to give me 9. And I'm going to cheat a little bit here. 25 times 8 I know is going to give me 200. I'm not going to do it bit by bit. So my answer for the area of a circle with a diameter of 16 centimeters is going to be 200.98 centimeters squared. Okay, and that's the two skills we have with circles now covered off. We can work out the circumference, we can work out the area. In the next video I upload, we're going to combine that with our work with other 2D shapes, with prisms, with rectangles, with triangles, and we're going to look at putting together some composite shapes, whether that's working out perimeter around those shapes, the area inside those shapes, or possibly a little bit of problem solving. You've now basically got all the tools you need to answer any question in this unit of work. Okay, I'll pop the other video up shortly.